So today, SEER for hardware orientation, getting started, some of the things to be aware of, some of the tips and tricks that will make your life easier, and everything to do with SEER for hardware. So we have our opening screen here now, and in front of us you'll see standard SEER interface now. Our recent programs are listed in the middle, so you're able to have a look at the past projects, restart them, go back into them if that's what you want to do. Else, what we're going to do today is start a new estimate. So we can go File New, or we can click on New Estimate, and this will invoke this dialog box. This is the project settings. So we got to give it a project name, tell the model who we are, and then we can select knowledge bases for what we believe to be consistent across the rest of this project. So today we're going to do an airman product. We're not going to be looking at operation and support in SEER, although just to be aware, it's very capable of doing that for you. The acquisitions category is turning on the level of rigor for development, for production, turning up, turning down, whether you want to build to print, less development, or make full development. So today we're going to make it full development, full production, and we're going to build it to a military full standard. If you're unsure at any point in time, we can have a look at these. We can select one of these. This is the help, and we can go through, verify that we have the right one selected, and we're happy. We can go back in and we can click on the finish, which will take us to the standard 4-pane configuration, which you'll see shortly, or we can go next, where we can put in our prototype quantity, and we can put decimal points in there, so we can have 2.5 prototypes, and then the production quantity for up to a total of 25 years. So we're going to build one in the first year, we're going to build one in the third year, and we're going to build one in the 5th year, and that's all we're going to build. So it's obviously something rather big. At this stage, again, we can finish, go to the 4-pane configuration, or we can set our project parameters and verify they're what we want to do, what we're working in, and so on. So our outline numbering is we're starting at level 1, which is correct. Our fiscal year starts in April, so we'll put the 4th month in. We're working in current EC, economic conditions, 2020. These are productive hours per month for production. These are operator hours per month for operations and support. Here we can swap currencies, so we can work in sterling, we can work in euros, but today we will work in US dollars for our American friends, and we can also work in multiple currency. So the way it's set up at the moment, the project level will be in US dollars. Every work element we insert will default to US dollars, but you can then edit that. So you can say the fuselage is being made in Europe, the engines are made in the UK, everything else is made in the US, and so on. So you can actually mix and match that, and everything is rolled up to the top level for multiple currency. Precision, remember that we're working at a top level, rough order of magnitude, and realistically cost output to anything more than 0 or 2 decimal places really aren't necessary, because we're looking at big chunks of effort, very top level, rough order of magnitude estimation. So we can set it lower, or we can set it to 0, whatever you want it to be, and this will be reflected in all of the reports and charts. We can change the names, so we can have alterations to this. So this could be development services, this could be systems engineering team, whatever you want it to be, and that will then be reflected in the reports and charts so that you can have something that's reflective of your organization. Click on OK, we're happy with that. Click on Finish, and we instantly go to our standard 4-pane configuration, our work element window, where we put the building blocks of cost in, whether it be mechanical, whether it be electronic, whether it be electrical sensors or ICs. We can build them in here. For every line item that we have here, we have a corresponding set of inputs, the parameter view window on the top right, and then at the bottom we have model outputs, reports and charts, which will tabulate across the bottom. And as you can see, we have a selection of reports and charts that are open here. nothing in them, everything's empty, we've not done anything to it. So the first thing I always do, personal preference, you don't have to do this, I think this is yellow, which indicates we have system level cost turned on, which is reflected here. So I start from a position of I don't want it on. So I turn it off. This goes white, so it's turned off system level cost. And then I'll turn that back on when I feel it's appropriate to the level of which I feel appropriate for the job that I'm trying to estimate. It may be the case I'm going to do system level cost at lower level work elements and a little bit at the top, but I decide that once I built my estimate and I have a better understanding of what's going on. So we can now right click here. We can insert a work element, or we can come to the work elements tab and insert a work element, which I will do. And then we give it a title. We select the type. So what type of work element is it? A roll-up is like the signal at the top for grouping things together logically. Electronics are PCB boards within the model. Mechanical structural. Site and add-in, or site, sorry, is operations and support work elements. This is where it's going to be operated to or maintained from or both. An add-in is where we cover costs that you know of, but we don't. So it may be a license fee, a shipping fee. It may be a flight test, something that's not covered by SEER for hardware that you need to enter into your estimate for completeness. Now, EOS is electrical optical sensors, and this is a very good plugin to SEER for hardware for doing spies in the skies, satellite optics, lasers, calibrators, mechanisms, coolers, and all of the things that you would expect looking down on you from the sky, plotting weather, whether it's looking at mapping, sorts of things that are looking at surveillance may be done, and you can estimate that using the electrical optical sensor plugin. We're not covering that today. However, for awareness, I think you should look at that if this is of interest to you. And then the other plugin is ICs for integrated circuits, and we cover ASICs, the application specific integrated circuits, and the FPGAs, the field programmable circuits. So these are all optional extras. You can decide whether this is important to you or this, or you can have the core model at the top. So today I'm going to put in a mechanical structural, give it a name, and I'll call it a wing. And it's a wing composite. So I need to find something applicable in the application, which is my next step. So with SEER knowledge bases, the application will set everything. So this is going to set all of the parameters on your behalf. Once you've selected that one, it will then get further refined by the platform. So it's air-manned. It's going to have a little bit more rigor and testing and so on associated with it than maybe something that's industrial. It's got to be critical. We're not looking at operation and support. We're making it, so we're turning on full development, full production, and to the standard that we're building it is military full. Class are user-defined knowledge bases, which you can put in things like labor rates, you can do entire projects and so on. So that's another option for you, and that will have the highest precedent in the model because we believe you know best. So we need to check this, but we don't know what to look at. So we click on this one, and I'm looking for wings. So I can come down to W's. Oh, here we go. And we have a nice selection of wings. We got primary structures, we got composite automated process, and that's what we're anticipating we're going to be doing. So this is the knowledge base I will check. Let's read the help and go for that selection. And here we go, come to the bottom, automated process, composites, primary structure, wing section. I'm happy. All I need to do now is click on OK, and we have inserted our first mechanical work element identified by the little pair of pliers here. It's come in with all the parameters set on our behalf by the knowledge bases. So the knowledge bases are full of knowledge to get you started very quickly, very easily. Things to do with schedule, it's picked up today's dates and so on. It's inherited the production quantity from the top level. Labor rates have come in based upon the US dollars, the economic conditions, and so on. Fully burdened, including profit and fee, but excluding profit. Right, so what's missing? So it's not going to give us a cost until we enter a weight or a range of weights. Now, because we're looking at this from a top-down perspective in the estimating world, we're looking at it at the conceptual stage, maybe limited information, early design, we're trying to do it very quickly, we're up against a deadline. We can put 3 estimates in. So we're not sure of the weight. I double click it, it brings up the dialog box, but we do know that it's going to be at least 2,000 pounds. It could be as high as 2.5, but weights have told us if it's any more than 2.7, it won't take off. So we have that. So we can put notes and attachments in here. Weights data from Steve. He told me today, so we can expand this note. We can put a date and timestamp on it, so we've recognized when he did it. We can attach the file. I'll just select anything, which is another SEER-H file. We can attach that. We can insert file links, and we can capture the total data assumptions all the way through your estimating process. We can do it at any work element level. Click on OK. We can do it over here. We can put notes in against that work element, so we can say this is a composite design, blah, 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 and so on. So we capture all of the notes. So we have an attachment, so we have a little paper clip. If I put a note, and again, you can see all of this information around. So let's put the weight in. So it's going to be 2,000, 2,500, 2,700. Not sure where that went. Click on OK. So we've done it. We have actually got numbers. So if we look at our detailed estimate, we've selected knowledge bases, give it a title, we've entered a weight, and now from that little bit of effort, you have got a huge amount of detail. Look at all these development activities we're covering: design, prototype hardware, engineering test, integration test, systems engineering, and so on. Really good list. Material, production cost and fabrication, integration and assembly, sustaining engineering, tooling management, program management, tooling maintenance, I mean. And then further down, we've got some logistical information relating to the MTBF and hours to mature, etc., if we were doing operation and support. So what I did there was I simply double click this one and it pops out. You can drag this onto a second screen. So if you've got 2 or 3 screens at your desk, you can put your results on one, charts on another, information window on the inside. If you have a large WBS, you might want to go into View, and then from the View menu, we can click on full length WBS and you can move that around automatically. And one of the things you can do is you can change the background color, the font size, the type of font you have, screen positions, and so on. And once you've done that, and you've got the reports and charts open that you're happy with, all you have to do is go Options, Save Configuration, and it will fingerprint that for you for when you start. So it's going to know to start in US dollars, 2020, etc. That's all captured. So that will save you a lot of time. So go Options, View, and there we go, back to the 4-pane configuration. So this is how we go about it. So we provide knowledge bases. The knowledge bases are captured for a best fit across a range of wings. We don't know whether this was a military aircraft wing. We don't know whether this was a commercial aircraft wing. So we need to, best practice is critique some of these inputs, have a look. Are we comfortable with the material composition? So here we go. Have a look at these. Are we happy? And I would go, I was expecting a little bit more composite. So I might go 30, 50, 70. So I'll just increase that a little. Past knowledge is my reference for that one. Not a very good reference. So it's good practice to make your likely equal 100%. So we got 50, 55, 60, 70. and we're going to get rid of the still. So we're going to put that to 0. We know there's not going to be any still because of weight constraints. Click on OK, and we've made that correction as well. These three here are very important. Complexity of form. This rates the level of its own internal assembly. Complexity of fit rates the overall tolerancing of the part, and construction process rates the labor intensity of that process also. So for myself, I put the best weight I can possibly find in. I can put a volume in. It doesn't stop you getting a number, but it's obviously best practice to put that in, and a range of weights maybe, because I don't know, I haven't calculated it. Click on OK. Let's move that out the way, and OK, that's in there. And you'll see with this one, if I go to the quick estimate, which is our interactive estimate, which is here, I can right click, quick estimate options. I can look at what's of interest to me, what matters to me. So I want to have a look at things to do with my average production unit cost, my material cost. I want to have my development cost, I don't know, my schedule in there, and so on. So you can have a variety. And as I check them, they will appear in the list. So my quick estimate has got quicker, larger. I can set a reference, this little push pin at the top here, give it a name, and I can come in here and I can see what is the impact of making this more automated. So my construction process is the labor intensity, and every parameter has help. So you can look at the help, read the help, and you can say, so having a look, structural composites, yeah. So I'm going to set this one nominal, maybe a little bit lower. What does low say? Structural composites again, right, minimum labor intensity. So I like low. So I'm going to set that one to low, click on OK. And you can see that that's had an impact of 9% on the APUC, the average production unit cost. And it's made it was a good decision. I might keep it. So I could basically right click here, clear reference, takes that away, press F9 to bring it all back. And there we go. We've had a change. We've updated our estimate, and I could have put a note in there, and I should have put a note in there. Things down here. So of this is how much of this is new design. Now this wing is going to be pretty well symmetrical. One wing is going to be the same as the other. Maybe we can consider new design. How much of this is new design? I think it's probably going to be 40, 60, and no more than 70%. And that's going to have a big impact. We look at our 59 there and come down, and we brought that down. The replication, we're going to have some good replication within this wing, 40, 50, 60. Again, this is going to reduce our engineering cost dramatically. Design complexity, so where do we fit within the state of the art? Is this blue sky technology? Are we trying to make this out of a process that's never been done, verified before? Is this a new material? Is this something completely off the wall? In which case you would rank this a lot higher. This is to do with technology readiness levels. And if I come down here, you'll see we have reference to the TLRs and help to help you set that as well. Subsystem integration level is the difficulty in integrating these interfaces with the fuselage, with the body of the aircraft, with the other things that need to attach to the wing, the engines, the fuel tanks, etc. So you can rate that here. And then coming down again, how good are the people? How good are the developers? How good is their equipment? So they may be the greatest developers on the planet, and they may have just changed from one version of a CAD tool to a new one. They're a little bit slow, a little bit sticky. They haven't quite reached their full production capability yet, so you may want to bring that one down. And then we live in a world where governments change, ministries, new technologies come along, and the requirements volatility on a long lead time item is likely to change. So we can capture that here. We can reflect that. We can say there's going to be frequent moderate changes. Could be later on where there's going to be no changes. I'm not going to change it today, but that's what that's all about. So requirements, volatility. And then the same in production, how good are the people? How good is their equipment, their level of tooling, their expertise? Are they familiar? Are they building a wing? When last week they were building washing machines, so they're not going to be very experienced. They're going to have a lot to learn, and so on. So it takes you down through that tab pretty well. This is just to do with the probability. So this is the most likely point of the estimate with the distribution based upon your least or likely and most inputs. We can use this within system calculations and subsystem totals if we want to. And the total number of drawings doesn't have an impact on the cost, but it will give you a metric on we're doing, I don't know, $10,000 per drawing and so on. So you can get a handle on how productive you are in that respect. In the schedule, the model is going to give you an optimum schedule. So we have a development schedule here. It's calculated. We have a cost. And you'll notice that SEER is saying it's going to be 0. So in the world of Gallerith, in the world of SEER, 0 quite often means let the model do its work. So what's going to happen is it's decided that this is the optimum schedule based upon the complexity of the part, the weight of the part, the type of the part, etc. It also sets up these PDR, CDR, systems validations, etc. based upon the schedule. And then you can also vary the distribution of the people. At the moment it's defaulted to the rally, so we're ramping up at the beginning, tailing off at the end like a. But the other thing to consider is the learning curve. So we have learning within the model, we have prior production units, and when do we want learning to stop? So these are 3 critical cost drivers to be considered. How quickly am I going to learn? Has this organization made these before? If so, tell the model that and it will cut the cost because you don't want to pay for the low level production units time after time after time. And then at what point do you think we're never going to get any better, we're never going to get any quicker, we can stop learning at the 100th, the 1000th, the 10th, it may be a space project, and so on. And then finally at the bottom, it's just brought in the production quantities. And you'll notice these are bright blue, they're in chevrons, and that means that's an inherited quantity. And if you wanted to change it, you have the ability to uncheck this box here and enter a value, but I'm not going to do so. And that's that one there. Labor rates and cost factors, so it's coming in with default rates. If you want to change the rates and they're all the same, you can double click here, you can uncheck that box and say we're doing it for 125, clicking on OK. Same here, we can check it, change them all to 110, click on OK. But then you might say that the manager's on 120, the fabricator is on 90, and so on. So you do have that capability to set them individually. You can also overwrite the raw material, so you can put in a prototype material cost per pound and a production material cost per pound if you wish to, so you can take control of that if that's of importance to you. We have simplistic wraps and fees, so you can attempt to add other wraps and fees if you want to try and emulate a cost rather than a price. And then if this is a throughput, a purchase part, you can tell the model what percentage of this item is purchased, what the prototype or production cost is if you want to do so. We're not looking at operation and support today, but the other key one to mention is when we look at this one here, we have all these categories, but SEER also breaks them down into the people. So we're looking at the people and we can reallocate these people if you wish to. So within design, we got development managers, systems and engineer. The lion's share is in design engineering, as you would expect, but you could say, I want this to be 75. I'm going to take a bit out of here, a bit out of there, a bit out of test. And you can move that around as you see fit to reflect your organization. And we can do that for development and production if you deem that necessary. So we've had a look at that. We've got our reports, we've got our charts. So as we start generating numbers, we've got allocation charts, we've got schedule risk analysis. So what you'll see here is a nice S-curve. So the model in development is turning out this number here, the 50 percentile by default. So it's telling us now what the likelihood is of achieving it at the 90 or 99, the 1%. So there's only a 1% chance we'll do it for 15.6 million, but there's a 99% chance we'll do it for 72 million. So we've got a good range here. We must have a fair bit of uncertainty in our inputs. Production is the same. What other ones here? Total cost risk, annual expenditure, where the money's coming in and out. We have Gantt charts. We've only got one work element, so we can not do much with that one, but we can move them around if we need to by right-clicking and sliding the bars around. So the work elements themselves are coming in one at a time. And here, if you want to do another one, you can right-click and copy, right-click and insert paste, double-click, change, give it a new name. I don't know, something else. And OK. And then you would probably change the knowledge bases and so on and so forth. Now our project Gantt has got two, they're identical, and we'll come into our parameters and we'll just make a random change here of saying this is 100% aluminium. Click on OK, and we'll make all of these 0, just so we have a difference in cost and time, and just to show you. There we go. So we've made some changes to that one here. So all the way through, we have this ability to do so. We can insert other work elements. We can come here. We can insert an electronics line item. It's a PCB. And again, it has its own individual set of knowledge bases. So we can say this is going to be some controller, systems control. Click on OK. Now the main difference this time, it's going to come in with a number of printed circuit boards, the size of the boards, the type of the boards, and we can change this to other materials if we want to, and there will be an impact in cost. When we look at the circuitry composition, the percentage analog, digital, and hybrid, look at the buildup of costs onto the knowledge base, number of discrete components, surface mounted discretes, integrated circuits per PCB, clock speeds, etc., all the way down through until you've covered the composition of the boards, technology, packaging density. Do we have any custom chips usage? So if you haven't got the IC plugin, all is not lost. We can start putting in unique chip designs where they fit in the development and production world, whether they're custom or not. Then we come down to similar things. We have fault detection, fault isolation, and then lower down again, we have prototype insertion method and production as well further down. So we have this to consider as well. But the other parameters are common as they were in mechanical. So we can build this. We've done a what if, we've done a trade. We can exclude the work element but leave the work in here if we wish to. We can insert further work elements. So I'm going to put in one more. I'm going to put in a roll up. I'm going to call it mechanical. And OK. And now I want to demote that one, so I can use the demote button. I could use the same button there, or I can pick it up, drag and drop it in, and put it into there as well. So come to that one, and it will insert the roll up at the next available space. And again, click on OK, goes there, demote, but I want that to go before that one, so we move that to the top. So you have this ability to control the tree. You're in total control of the WBS. You enter as many work elements to the level of decomposition that you need to. And I think perhaps that is probably enough for the day. We've covered a lot. We've inserted work elements. We've looked at some of the parameters, some of the inputs. We've manipulated them. We've looked at reports and charts and setting references. We've excluded work elements. We've promoted, demoted, move up and down, and so on. We can lock parameters. We can hide parameters. So if we come here, just quickly show you, come to the labor rates and cost factors. We're going into negotiation. I don't want my rivals, my customers to come here. I want to hide them. They disappear. Hide them. they disappear. I've got other ones which I don't want to change, so I can lock them. And similarly, you just unlock them in exactly the same way as you lock or unhide in the other way as well. So I will pass you back to Steve. I hope that's been informative, and you will find this will help you start to set the model up, to start inserting work elements, select knowledge bases, explore the help, explore the reports and charts, and have a nice day. Stay safe